Alright, good day and welcome back to Everything Mathematics. Today we are going to continue our series of trigonometry. Well, this week, as a matter of fact, last week we would have started looking at the concept of what is trigonometry, and we also went on to look at the three main trig ratios, trigonometric ratios that we use in high school. And I made it clear that because of last week's video, we look at each concept separately. It is very easy to pinpoint which one we're using. But the real challenge here honestly comes when you know all three and you're given a question. And this is why we're going to practice today. So today we're going to see if we could put to the test what we learned last week. So what is our objective for the week? We should be able to identify the correct trigonometric ratio to use when finding an unknown side. And of course, we're referring to triangles. Good. And last but not least, of course, we're going to be using the trig ratios, naturally. Oh, I have ratios twice here. We're going to be using the trig ratios to find unknown sides of right angle triangles. So without wasting no time here, we have our first one. Of course, you could pause, give it an attempt, and see if you could solve it. But here now, they ask us to find P. They didn't give us any further instructions. Last week again, because we did each video separately, you knew exactly whether we had to use tan, whether we had to use sine, or whether we had to use cos. But here now we just presented with a problem. And now we need to be able to identify which ratio are we using. By the way, in case you're still wondering how to recognize the three ratios, I always remember the word so, ka, toi. Once I recall this is everything I need. So is sine, opposite over hypotenuse. Ka is cos, adjacent over hypotenuse, and tan is tangent, opposite over adjacent. So here, let's see, we want to find P. So let's examine what is given. We have a given angle here, so we're given theta in this case, and we know that theta is 20 degrees. Here also we have the opposite, because remember the side facing the given angle is known as the opposite. So we were given the opposite, and in this case the opposite is 8 centimeters. So that leaves us with this side P, which we want to know and is unknown. So which trig ratio involves the opposite and the adjacent? Of course, we need to know that this side is the adjacent because we know that the side facing the 90 degrees will always be the hypotenuse. So we know this side here cannot be what we're looking for. So we're looking for a trig ratio that involves opposite and adjacent. And look at it right here. So how do we find P? We must use tangent in this case. And that is how we identify which trig ratio we use. So here we say again, tan theta is equal to opposite over adjacent. And once that's out of the way, we substitute our values. So we have tan 20 degrees is equal to the opposite, which is 8 cm, and we divide that by P. P is the adjacent that we don't know. So to find P, we basically, again, we make P the subject of the formula, and that will leave us with 8 divided by tan 20 degrees. And from here, the calculator could do the rest for us. So I find tan 20. If we want, we could round off, or if we're using the calculator, we could just use all the values. Usually when I teach students, I encourage them to round off to at least 4 decimal places in the event that they have to write down the answer, and to also promote as much accuracy as possible. Because oftentimes you get an irrational number when you do these trig ratios on calculator. And here I am getting P to be approximately 22 centimeters. And that is to the nearest whole number. Well, I don't feel like writing to the nearest whole number. But that's 22 to the, I will round off everything to the nearest whole number. So that's 22 to the nearest whole number. And that's how we get P. So in other words, this distance here is 22 centimeters. I trust you got that too. Let's move on swiftly to number 2. Number 2, now they ask us to find T. And straight away, I notice that T is opposite the 90 degrees. So right away, I know that I need a trig ratio in which the hypotenuse is involved. And there are only 2 ratios where the hypotenuse is involved. Is it a sine? Because you see there is so, opposite over hypotenuse, or there is cos, so ka toi. Good? Notice in the cap part of it, there is also an hypotenuse. So then we have to make sure now, is it sine or is it cos? Let us see what is given. So they gave us the angle, of course, in this case. And only sides we're finding because that's what we did last week. This week we'll be moving on to finding the angles with the trig ratio. So here we given theta is equal to 45 degrees. So that's a given. And facing theta, we know that is our opposite. So in this case, we have the opposite again. And that sells it all. So we know the opposite is 9 cm. Remember, the opposite is the side facing the 90-degree angle. So we're given the opposite, we're given the angle, and we're trying to find t. And t in this case is hyp. That's the hypotenuse. So that will be t. So which trig ratio can we use here? Sine. Only sine would work. Cos would have worked if we had the adjacent, but we're not given the adjacent. The adjacent would have been this side over here, but we don't have nothing for that side, so we cannot have two unknowns. Remember, only one could be an unknown. So with this in mind, all we have to do now is state the formula. So sine of theta is equal to SOHCAHTOA, opposite over hypotenuse. And we just substitute our values. So we know sine, we know theta is 45 degrees. So that sine of 45 degrees is equal to the opposite, which is 9, divided by t, which is the hypotenuse. And in this case, again, we just cross multiply, and t will be equal to 9 divided by sine 45. And that will give us a value of t of, again, I'll just take my calculator here, sine 45 is equal to this, and then 9 divided by the answer, I am getting 12.7, and again, I did start rounding off everything to the nearest whole number, so that's 13 cm. Good. So t here is 13 centimeter. Oh no, not centimeter. In this case, I'm dealing with meters. I put centimeters here too. 9 meters. So here will be 13 meters. And that's our answer. That's t for us. Good. So bear that in mind. Moving on. So here we have our next one. We have Q. And again, let's just establish. So there is no hypotenuse here. No hypotenuse. So right away, I know that this is tan, because tan is the only trig ratio which we don't deal with the hypotenuse. So without any further ado, tan theta is equal to opposite over adjacent. So SOHCAHTOA. And here we know the opposite. In this case, the opposite is Q. And we know that theta is 60. Good. So let's just replace those values. So we have tan of 60 degrees is equal to the opposite, which is unknown in this case, Q, divided by the adjacent, which we're given as 13 millimeter. And here to find Q, we just cross multiply the 13 to make the Q the subject of the formula. So that will be tan 60 degrees multiplied by 13. And here you take a scientific calculator. So in mine, so if I put tan 30 is equal to this, and I multiply that by 13. No, I did something wrong. Sine 60, not sine, tan 60, I have to get that first, and then I multiply that by 13. According to my calculator, I am getting 22.5. Why does this answer look so familiar? So this is the same as, to the nearest whole number again, is 23 millimeter. I'm rounding off all my answers to the nearest whole number, so please take note of that. So this distance Q here is 23 millimeter. Moving on. Number 4, I think this is the last one. So here we have 70 degrees, here we have M, we have T. So let's see. We don't have the opposite, but we have the adjacent and we have the hypotenuse. So that means we have to use cos. So cos theta is equal to the adjacent, so SOHCAHTOA, the adjacent over the hypotenuse. Good. The hypotenuse. Hype. Good. And theta in this case is 70. So we're looking at cos 70 degrees is equal to the adjacent is m, because remember the side facing the 90 degrees is the hypotenuse. So here m is the adjacent and the hypotenuse is 16. So we're just replacing the values, we're substituting the values with what was given. And here to get m again, we just cross multiply the 16, and that will leave us with m being equal to cos of 70 degrees multiplied by 16. And that gives us an answer of what? Let me look at my calculator. Cos of 70, I'm getting that. And then I multiply that by 16. And that gives me an approximate answer of 5 meters. So m, this m here, is approximately 5 meters rounded off to the nearest whole number. I'm getting 5.4723. So that's approximately 5 meters. And this is how we go about using trigonometric ratios to find unknown sides. I trust you saw pick up the pattern as to how to identify which ratio we use, because as I said, that's where the problem usually comes. Do we use sine? Do we use tan? Do we use cos? You just have to look at what is presented. And remember, always only one side will be missing, or one something will be missing. It could be the angle, it could be the adjacent, it could be the hypotenuse, or it could be the opposite. Only one would be missing. So you look at the formula. If nothing I did make sense, then you look at all the formulas and see which one you could use and only one is missing. Again, of course, that way is more like troubleshooting. If you know the sides and you could examine what you're given, then it's a lot easier. But if you can't figure that out, then yes, the other way out of it is by examining whatever only has one element missing. So that should bring us to the end of today's video. Again, as always, feel free to subscribe if you haven't as yet. Share with your friends so that they can get on board with everything mathematics. And like, of course, or comment if you have any question, anything you would like me to do, or anything that was not clear to you. So until the next one, you take care.